This is a video prepared for Engineering 1332 at Oklahoma State University. This video is primarily prepared for my teaching assistants who will be lecturing on this topic this week, but we will probably make this video available to the students who are in the class who maybe want to go through this material again, but again, primarily aimed at my teaching assistants. And so what we want to do is we're starting the idea of computer-aided design with SolidWorks in this lab, and some students may be encountering the idea of CAD and geometry and drawings for the first time. And so this is a nice document from a couple of people at MIT that I've worked with, Ernesto Blanco and David Wilson, and I think it's a very nice introduction to the idea of 2D and 3D graphics and drawings and purpose of drawings and those kinds of things. So here we go. There is a nice outline in the document, and we will also be making the web link for this document available to the students should they want to look at it in detail after class at some point. And so we get into, I'll be scrolling, the idea of the 3D world. And so this shows an interesting three-dimensional kind of machined block, and this block is a 3D real thing, but historically engineers have had to communicate their ideas for 3D geometry in the form of two-dimensional drawings. So a system has been put in place to go from the 3D thing that is in the designer's mind and will eventually need to be created as a 3D thing that will pass through two-dimensional drawings. Okay, so just a little bit on terminology. This same kind of block has been drawn in something called an isometric drawing, and an isometric drawing has this form of, if we're drawing rectangular things, this edge is parallel to this 30-degree line, this edge parallel to this 30-degree line, and this edge is vertical. And so all things vertical show up as vertical. Widths and lengths show up 90 degrees from each other, but really the angle between widths and lengths are not 90 degrees. They're greater than that on the page. And so this is one of several means of three-dimensional viewing called an isometric drawing. What we need to do to communicate this, though, into the 2D world with drawings on a piece of paper is go into something called orthographic or multi-view drawing. So if we take this box, and the block, and if we were to place it in a glass box, you can see the glass box here with a top, a front, and a side, and then we look straight down from the top and we trace what we see, we would see these lines on this flat plane. And then we move to the front and we trace what we see right onto the glass box. And then from the side we trace only what we see from the side on the glass box. We will now have come up with three different views of the object from three different directions, and those are called the three views. Then if we want to put this information onto a piece of paper and create what are called the orthographic views, we simply unfold the box. And so the primary view is generally the front view. The top view would be placed above the front view, and the right view or the side view would be placed to the right. And so these would be the three views, top, front, and side, of this 3D object. Quite often an engineering drawing will have the three views and an isometric view or some other three-dimensional view on the drawing, with then an awful lot of detail added to clarify what's going on. Now, you don't always need three views of an object to fully describe it, because sometimes two of the views would end up being the same. So excuse me, this is an object of revolution. This feature right here is a cylinder. This one is a cylinder. So two views are sufficient to fully describe what's going on, in that we have two cylinders. They look like rectangles from one view, but when viewed from the right hand side we would see two circles. And then to fully detail the thing, we'll put these things called dimensions onto the drawing. And so now we turn to dimensioning. In some cases, an isometric drawing with size information called dimensions placed in the various directions could fully describe the nominal geometry of a part. But this is not the traditional engineering way to create a drawing of a part that is sent to people who will end up making this part. Okay, the more traditional way is make the 3-view of the part, the 3 orthographic views, and place dimensions in the appropriate orthographic views. Okay, and so one of the reasons, okay, well, we're going to get into a little bit of detailing before we go further into dimensioning. There is more dimensioning information further down in the document. We're going to take a little brief step into something called sectioning. For a part like this one, we may or may not be seeing every detail of the part from this particular view. What if on the back face, back face of this cube that we can't see, there were a hole going halfway through the thickness of this upper surface? Okay, that would be totally hidden from us. We wouldn't be able to see it. So we'd need maybe multiple isometrics to then be able to gather some of those details. There might even be internal features that we'd have to do a lot of rotation of the part to see. One technique for showing interior details of a part is something called sectioning. And the basic idea is take a part and imagine that you were going to use a saw and just slice it into 2 pieces. So imagine we have this piece with this circular piece on top, apparently a hole right there, and if you can see this little line right here, we're going to slice it right along that line. If we do slice this part that way, this is what we get. Can you see this part has been sliced in half? And what we learn from this thing is that this hole goes all the way through the part. We couldn't tell that from this picture. What we also learn is that there's some interesting detail going on inside of this hole that we really couldn't see well in this picture. And if we were to turn this, rotate this so that we see this side right here square on, we'd get even more detail out of it. Okay, and so we've now done that. We've taken this one, rotated it so we see the thing square on, and then we can see some additional geometry information of what's going on this hole. This is called a section view. Okay, we're going to skip the drawing tools. Many times the geometry we want to create is made of multiple parts, multiple physical pieces. When that's true, that's called an assembly of parts. And so in this case, we're showing an assembled object, but we may or may not be able to tell where the different parts are divided from each other and what is one part and what's another part. But if we take this assembly and we produce what's called an exploded view, which means so now we know that this is all one piece and it's been raised up physically to reveal that there are 2 interior pieces sitting here, and this would be even better if these 2 rings were raised up a little bit, because I suspect that they are totally separate pieces. And then we have a piece on the bottom which is different than the piece on top. Okay, so by separating the physical pieces in a drawing, that's called an assembly exploded view. Okay, now this document gets back to cross-sectional views. We diverted from that for a little while. And so this would be a cross-sectional view of the assembly that we saw above. So we're going to be doing a vertical cutting plane. Cross sections are generally indicated by a line and a couple of arrows pointing in the direction we'll be looking. The line tells us where we cut. The arrows tell us where we look. Typically a couple of letters, A and A, says this is section AA. And then when we actually show the thing cut, we'll label it as section AA. We'll see that in a moment. So here is this object cut in half and viewed as section AA. What it would probably look like on a drawing would be an orthographic view from a direction with the cutting plane and the direction of viewing. Sometimes we don't want to cross-section the whole thing. This isn't a big deal, but because SolidWorks will have tools for doing this. But for this part, this one says I'm going to start and make a cut here in this direction. Then I'm going to turn 90 degrees and make a cut there. And then I'm going to go in that direction. And this arrow says that I am looking straight to the left. This arrow says I'm looking straight to the left. And this is my cut region. And what it gives me is a half section where the top half has been cut in half, but the bottom half has been left intact. Okay, another half section showing a cut from the middle to the left shows the cut region. From the middle to the right is showing the uncut region. This shows what's typically done if there's a hole pattern and we do a section. We typically don't make a straight cut, therefore showing only this hole on the left and totally missing a hole on the right. We typically don't do that. Instead, we would do a rotated or a bent cross section. We'd say we'd cut here, get to the middle, turn the angle a little bit, and then we would see the holes on both sides. More typical way to do it. Again, SolidWorks has tools for doing that, but we're going to be giving you geometry quite often in the form of a drawing with orthographic views and sections and details and those kinds of things. So right now we mainly want you to be able to read those drawings. Now we're getting into the idea of dimensioning. The purpose, I'm going to read this. The purpose of dimensioning is to provide a clear and complete description of an object. A complete set of dimensions will permit only one interpretation needed to construct the part. And there are some guidelines on dimensions. It says, first of all, they should be accurate. Correct values have to be given. Clearness, they must be placed in appropriate positions so you know exactly what's being dimensioned. Completeness means nothing must be left out. Every dimension necessary to make the part must be there, but also we don't want to have too many dimensions where there could be potential conflict. Okay, and they need to be readable. The readability issue, engineers in the past spent a lot of time working on their handwriting skills for doing drawings and dimensions. We don't do that anymore because we have CAD available and we're not relying on your very nice handwriting. This shows some features of a dimension, including a dimension line that tells what length is being dimensioned, the dimension value, an arrowhead on either end. It shows an extension line right here that it takes this line right here and extends it out so that we're placing this dimension on the outside of the part. It shows typical arrow sizes, which mattered back when we were doing things by hand. Okay, and so this shows a part that has been dimensioned. You can see extension lines. You can see the dimension being placed. Sometimes the arrows are placed on the outside of the dimension lines. Sometimes the arrows are placed on the inside. We'd generally prefer to place them on the inside if there's space available. You can see the extension lines. This thing is called a leader line because there are no straight lines that would help me dimension this circle. So I place an arrow that points to the circle, and I say that this thing has a diameter. That's what this O, or circle with a cross through it, means, a diameter of 6. And this says there are two of them, 2x, one here, one there, but I'm not going to bother to put a dimension on this hole. Just know that there are two identical holes. And so this shows some sample nice dimensioning. Then the question is, if we're going to have multiple orthographic views, where should we put the dimensions? Okay, it says the dimension should be placed on the face that describes the feature most clearly. So if we have an object that has this cross section and it has been stretched in or out of the page so that when viewed from the side it just looks like a rectangular chunk of metal. Okay, so here, this might be a front view and this might be a right side view. So where should we put dimensions? We should put them where they really show up most physically and most clearly, like holes should be dimensioned, or circular things should be dimensioned in the view where they look like a circle. Okay, and sometimes we dimension diameters. This says a diameter of 25. This is a radius type dimension where we have a leader line with an arrow from the center to the arrow and a little leader line continuing on that says radius of 25. We have a dimension of 20 and we have a dimension of 5, both dimensioned from the bottom of the part. Notice the inside and outside kind of dimension. And so all of these dimensions here are most appropriate in this picture. The same information is available in this view, but every one of these things is much better here, except this length of 40. This length of 40 shows up, only shows up in this view, and possibly this step of 5 right here might be acceptable in this view. It's probably better in this view though. Okay, so you'll have choices on where to put your dimensions. Just a second, my phone is ringing and I'm going to stop it. Actually, I'm going to pause the video. Okay, continuing the video. All of this dimensioning is a tiny bit early. We will be having you create drawings with dimensions and wanting you to put them in the right place. Main thing we want you to do right now is know when we hand you a document that has dimensions on it, what they mean and how to read them. Okay, again, this shows a very trivial object being dimensioned. This shows a moderately more complicated object being dimensioned. This is a very useful technique here. When you have a series of edges, it's generally best to pick one surface and dimension them all from one surface, because in the end an object has to be made and an object has to be checked and measured to see if it's right. And the fact that all of these dimensions are being referenced to this datum surface is what it's called, would also say if they were going to inspect the part, they would measure all of these edges from that one part. Okay, this shows that the datum has been moved. Nothing terribly important there showing up there, I think. This one shows that there is a hold that has been dimensioned. Nothing super there. I think this is to be in contrast with the next picture where we round off this edge. And when we round off this edge, okay, this dimension of 60 can actually be computed from this dimension of 45 and this radius of 15, which makes this dimension of 60 redundant. And if we typed a 61 right here, then it would become inconsistent with the 45 plus the 15. And when you put too many dimensions on a part, there is the potential for inconsistency. And so what we do is, if we know we're placing a redundant dimension on a part, we put the word reference as for that dimension, saying this is not the primary thing that sizes the part, something else does, but if all the dimensions are nominal, then this would end up being a 60. Let's see. I think that is really all I want to say about this document, to give the idea of some things that you will be seeing. Let's see, I'm going to pause it and then bring up a 2D drawing for you to look at and comment on it, and then we'll be done. Okay, I've just changed windows and have brought up a engineering type drawing of a car wheel. And you can see the 3 views of the wheel. Now, most of this is too small to read, but let's go ahead and zoom in a little bit on some of it. Let's see, what kind of zooming can I do? That seems to be all it's going to let me do, but that's okay. So here's a front view of the car wheel. A lot of the angular features are dimensioned in this front view. Height information, noticed all kinds of edges have been dimensioned all from the top of this wheel. Overall dimensions, there aren't very many dimensions in this right hand view, but the overall size of the thing has been placed in this right hand view, and then together with the isometric, which you can sort of see right here. See if I can get this thing to go back out. So here's the overall engineering drawing. This should be enough information with some of the additional notes for somebody to go create this geometry and get it right and actually make the part that was intended. And that would be the end of this video.